if you've been watching the skies lately, then, well, space isn't just about the moonshot anymore. It's really a bustling hub of activity, moving at an electrifying pace. So this deep dive is all about giving you, your shortcut to being well-informed on the absolute latest in space launches and why it all truly matters. We're pulling today's insights directly from a recent Launch Roundup article. It's dated July 14th, 2025, and it details an incredibly packed week of launches from all around the globe. And trust me, there's a lot to unpack here.
Yeah, definitely. Our mission today really is to distill the most important nuggets of knowledge and insight from this roundup. We want to help you see beyond just what launched and really grasp the implications, for the bigger picture of space exploration and the space industry. It's about connecting the dots, basically, in a way that makes you feel genuinely well-informed.
Absolutely. And what a week it's been. We're going to dive into China's latest space station resupply. Then there's a truly historic maiden orbital launch from Australia. And, well, a genuinely unprecedented week for SpaceX, including major satellite internet deployments and a pretty significant reliability milestone. Okay, let's get into it. Right, let's kick things off with China's recent mission. This was the Tianzhou 9 cargo spacecraft, often called the Heavenly Ship, heading to orbit. It lifted off on Monday, July 14, 2025 at, 21.40 UTC. That's Coordinated Universal Time. It was lofted by a Changzheng 7 rocket, quite impressively, from the Wenchang Space Launch Site down on Hainan Island. So this mission is the latest cargo supply run for China's Tiangong Space Station. It was heading specifically to the Tianhe module's aft port and docked pretty quickly, too, about 3 hours after liftoff. And just for context, the previous one, Tianzhou 8, had undocked just before this on July 9th, safely re-entered Earth's atmosphere, broke up as planned, clearing the way for this new arrival.
Yeah, these resupply missions are absolutely fundamental. They're foundational for any nation aiming for, a sustained human presence in space. Tianzhou 9 itself is just packed with essential supplies for the Shenzhou 20 crew. Everything from food, clothes, other consumables, life support supplies, scientific experiments, and crucially propellants. They need that for station keeping the station in the right orbit, and just general maintenance of Tiangong itself.
Right. And a particularly notable detail for me was the inclusion of 2 upgraded Phoenician extravehicular activity suits for spacewalks, basically.
Oh, yeah.
These new suits, they have an impressive lifespan, 20 usages over 4 years, and they're directly replacing a pair that had already exceeded their designed 15-use lifespans.
That's right.
So this isn't just about bringing up new equipment. It feels like a clear demonstration of ongoing maintenance and significant upgrades for their long-duration spaceflight capabilities.
Exactly. And if you just look at the raw numbers, Tianzhou 9's cargo capacity is quite impressive. We're talking 7,400 kilograms.
Wow. Okay. How does that stack up against, say, Dragon?
Well, SpaceX's Cargo Dragon, which you might be more familiar with for ISS missions, carries around 6,000 kilograms.
Okay.
And Cygnus, another ISS supplier, is about 3,750 kilograms. And both of those, by the way, are actually slated for ISS missions pretty soon, too.
Right.
But what this Tianzhou mission truly signals, I think, when we connect it to the bigger picture, is China's real commitment to self-sufficiency and sort of long-term space independence. They're minimizing reliance on external resupply windows for critical mission components. It's a very strategic move, really, to secure their sustained presence in low Earth orbit.
Makes sense. So while China is demonstrating these sustained orbital operations, a really new chapter seems to be opening on the other side of the world, a truly historic moment for Australia. We're talking about Gilmour Space's Eris rocket and its maiden launch attempt, Test Flight 1, that was scheduled for Wednesday, July 16, 2025, at 7:30 a.m. AEST, that's Australian Eastern Standard Time, or 21.3 UTC on Tuesday, July 15th.
Yeah, and what's historically significant here, really significant, is that this launch from the Bowen Orbital Spaceport in Queensland, Australia, it's poised to become the first orbital launch from Australian soil performed by a sovereign-built vehicle.
Right, built in Australia.
Exactly. This really underscores the growing global space industry and the development of national capabilities outside the, let's say, traditional space powers. It's not just about a country launching. It's about a country building its own path to space, basically from the ground up. And it's also, I think, important to remember that getting to space isn't always smooth sailing, right?
Definitely not.
They had that previous attempt back on May 16th. It was stood down, apparently because a premature fairing trigger, basically the nose cone mechanism, was caused by an unexpected power surge from downstream devices, ground equipment, essentially.
An electrical glitch, then.
Yeah, something like that. But the good news is the article says the issue has since been mitigated. It just goes to show the very real complex challenges involved in spaceflight and, the meticulous work required to overcome them.
Absolutely. And what's particularly compelling about this rocket isn't just where it's launching from, but how it actually works. The Eris stands 25 meters tall, has a 1.5-meter fairing, making it comparable in size to, say, Rocket Lab's Electron. In terms of payload, it can deliver up to 215 kilograms to a 500-kilometer sun-synchronous orbit, or 305 kilograms to 500-kilometer equatorial orbits.
Oh, what's especially intriguing here, I think, is its unique propulsion system.
Yeah.
They have these proprietary Sirius hybrid engines.
Hybrid, okay. How does that work?
Well, these engines use a 3D printed solid fuel grain and then hydrogen peroxide as the oxidizer.
Interesting combination.
Yeah. The first stage uses 4 of these engines, and the second stage uses just 1. Now, a successful orbital launch would be the first for a hybrid rocket design ever.
Really? The first ever?
To reach orbit, yes. It could potentially open a completely new chapter in propulsion technology and maybe demonstrate a viable alternative to, traditional solid or liquid-fueled rockets, which I guess raised an important question for you. How do these new players and these new technologies, how do they shift the competitive landscape of access to space?
That's a fantastic point, and one I've been mulling over myself. Do you think a new propulsion type like this could truly disrupt the market, or is it maybe more likely to find a specific niche? I mean, what are the biggest hurdles a company like Gilmore faces in scaling up to really compete?
Well, I think a successful hybrid rocket like Eris could certainly disrupt the small to medium lift market. It might offer a simpler, potentially safer, maybe even more environmentally friendly propulsion method that could definitely carve out a new market niche, distinct from traditional liquid or solid fueled rockets. The biggest hurdles, probably scaling production reliably and crucially proving consistent flight heritage, getting those successful launches under their belt. But the potential is definitely there to significantly lower the barrier to entry for maybe smaller nations and companies.
Yeah, okay. The rise of new national capabilities like Australia's is definitely exciting. But, well, no one's setting the pace quite like SpaceX right now, are they? They've had an absolutely unprecedented week, really highlighting the intensity of the commercial space race.
Oh, absolutely. This kind of launch cadence really just highlights the intense race that's going on to deploy these large internet constellations in low Earth orbit. It's a fundamental shift, I think, in how we think about global connectivity and access to information.
So their schedule this week included 3 Starlink missions, and interestingly, one for Amazon's Project Kuiper, a direct competitor to Starlink.
Right.
The first Starlink mission was Group 15-2. That involved a Falcon 9 launching 26 Starlink V2 mini internet satellites into LEO. That was from Vandenberg Space Force Base in California, scheduled for Monday, July 14th, or possibly just happened as the article came out.
Yeah, and this particular Starlink mission, along with an upcoming Kuiper launch we'll talk about, it marks a truly remarkable company milestone for SpaceX. It's the 150th consecutive successful Falcon mission.
Wow, 150 straight. That's incredible. And that's significant, right? Especially considering.
Exactly. It comes exactly 1 year after that anomaly they had on July 12, 2024. That was during the Starlink Group 9-3 mission, remember? When a second stage engine failed to restart.
Right, that broke that huge streak they had before.
Yeah, it ended an impressive run of 325 consecutive successful missions.
Yeah.
So this current 150 mission streak shows really significant recovery and reliability since then.
That's an astonishing bounce back. But does a company like SpaceX, with its really aggressive cadence, do they truly view an engine failure like that as an anomaly? Or is it maybe more like a predictable, albeit manageable, risk they've built contingencies for?
That's a perceptive question. I mean, while every failure is undoubtedly analyzed rigorously, their whole operational philosophy likely incorporates the understanding that such a high tempo of launches will inevitably encounter some issues. You just can't avoid it entirely.
Right.
The key, I think, is their rapid iteration and that robust recovery process, which this 150 mission streak clearly demonstrates. It's maybe less about avoiding all risk and more about quickly learning from it and mitigating it for the future.
Makes sense.
And the sheer numbers for Starlink are just, staggering now. Out of 9,165 Starlinks satellites launched to date. The article says 7,028 are now in operational orbits, just constantly expanding that global internet coverage.
Amazing numbers. Now let's pivot to the competitive landscape with Amazon's Project Kuiper. SpaceX is actually launching its first contracted batch of Amazon's Kuiper satellites. That's scheduled for Wednesday, July 16, from Cape Canaveral in Florida, carrying at least 20 satellites.
Yep.
This is a big deal, isn't it? Considering Kuiper is Starlink's main direct competitor in the satellite internet space.
It absolutely is. And what's particularly insightful here, I think, is how Amazon is diversifying its launch partners. They're clearly not putting all their eggs in one basket, especially to meet these really ambitious deadlines they have.
Deadlines.
Yeah, they have these aggressive FCC deadlines. They need to deploy the full constellation, that's 3,236 satellites, by the end of July 2029. But there's a more pressing deadline. Having half of them, 1,618 satellites, launched by July 30, 2026.
Wow, 2026 is coming up fast for that many satellites.
It really is. So to achieve this, it's not just SpaceX they're relying on. They've booked 2 more Falcon 9 launches, yes, but also 12 missions on Blue Origin's New Glenn.
Okay.
0.18 on Arianespace's Ariane 6.
Huh.
And a remarkable 38 missions contracted with ULA, United Launch Alliance. ULA have already lofted 2 prototype batches on Atlas V, and they'll transition to their new Vulcan rocket for the rest.
So they're spreading the load across basically all the major players.
Exactly. This isn't just about covering their bases. It's like a masterclass in supply chain diversification in what's, let's face it, a pretty volatile launch market right now. It helps ensure they hit those aggressive FCC deadlines, regardless of, individual rocket development setbacks that might happen with any one provider.
Very smart strategy. And just to round out SpaceX's intense week, there are 2 more Starlink missions coming up as well. Starlink Group 17-3 and 17-2. They're scheduled from Vandenberg on Wednesday, July 16th, and Sunday, July 20, respectively.
Right.
Both of these are flying directly south into sun-synchronous orbits. That means they'll pass over the same spot on Earth at the same local time each day, which is ideal for things like Earth observation. These orbits have inclinations over 97 degrees. And this marks the second and third missions to the Group 17 shell. That's a specific orbital highway, you could say, designed for this new set of satellites. And it's the first time they've launched to this type of sun-synchronous orbit in over 2 years, apparently.
Interesting. So they're filling out different parts of the constellation architecture now.
Seems like it. So, okay. What does this incredible week of launches really mean for you listening? We've covered an astonishing breadth of activity here, from the global ambition shown by China and Australia, both making their mark on the orbital stage in different ways, to the sheer scale and, frankly, the competitive intensity of the commercial satellite internet race, which is clearly being led by SpaceX and Amazon right now.
Yeah, and the rapid deployment of these constellations like Starlink and soon Kuiper is fundamentally changing global connectivity. It's bringing internet access to more remote areas than ever before. And meanwhile, you've got new players like Gilmour Space and new technologies like these hybrid rockets that are continuously pushing the boundaries of what's even possible in space, which I think raises an important question for all of us looking at the future of space.
Indeed. It really makes you wonder, with so many launches happening now, almost routinely, and so many new constellations and vehicles entering service, what do you think the next frontier will be, not just in launching things into space, but maybe managing all the traffic in space? And how might this continued surge in activity impact the accessibility of space, for future generations? Definitely something to consider until our next deep dive.